Okay, this is the one of the interview question. What is the difference between normal build process and yocto build system or build process? And next, yeah, yocto building process steps. Just a simple steps. This is the one of the interview question. Here, just what is the difference between normal Linux or normal means it's a normal process means I take an example in Ubuntu and yocto based Linux means how yocto based Linux. Here it's we see the some basic difference between normal and yocto. Just I am not going to in depth, just interview point of view. If you ask question to what is the difference between normal Linux build process and yocto based Linux means yocto build process means what is the difference and why using yocto based Linux system and what is the use cases of normal Linux based Ubuntu system. So this is the just I'm comparing to the normal and yocto based. Just it's the basics. Just interview point of view only I'll explain. It's not in depth. Okay. Here it's a purpose. General purpose OS for desktops and services means it's a normal Linux build system. It's a general purpose OS for desktops and services, and custom build OS for embedded system. It's a means it's a customized boards or custom builds for a specific board or a specific SoC for building that embedded system. Or means it's a custom build for OS for embedded system. It's a packages comes with pre-built packages and system utilities. It's a contain it's a when the OS itself it's a contain the things and full customizable and you build everything for scratch means here you have to specific a build means for SDK specific board like BeagleBone or TDA4 EVM or Raspberry Pi board. It's a specific board build environment build for everything for a scratch. Specific board you can install packages and for through this scratch. It's a size large compared to the yocto base. It's a normal Linux. It's a very large including many unnecessary components means and unnecessary components. It's a content, that's why it's a large size is wise, and optimize only include required components means here it's a particular board. What are the include files and what are the components are required, we only taken that things only. So that's why here it's a yocto based Linux system. It's a very size wise it's a less, it's a compared to the normal Linux build system. Uses package managers like apt means it's a sudo apt get update, and sudo apt get means it's a packages managers like we are using to the apt get update, apt get sudo apt get. If we want to the packages you can using to the apt. And here in yocto build system we are using to the bitbake to build from source. For building for source we are using to the bitbake. And hardware support wide range of hardwares means it's supporting to the all hardwares but need to be configured for specific hardware. Here it's a whatever you are taken a specific hardware you are building the yocto build for a particular hardware. That is the different hardware supporting means. Here we have to we are taken only for BeagleBone Black means you have to take a particular build for only BeagleBone Black. If you want to take in Raspberry Pi or TDA4, you have to you are particularly building for hardware specific. And next, flexibility, limited customization and full control over OS components and dependencies means all are dependencies only. Dependencies and management uses free built binaries and here in yocto resolve dependencies at compile time. Means it's having pre-built libraries, and but here resolve dependencies at compile time means you have to, whenever the compile here something is a dependency, it's based on that we can build that dependencies only, we can build in there only, we can update things, packages, everything. It's a compile time only we can fixing. Security regular updates but including unnecessary components. So here it's a regular updates, it means it's a Linux updates and something updates, it's affecting to the whole hardware. But here it's a more security as only required components only included, means it's a particular board you want to the updates, you can update, you can get the updates there only. But here it's an entire, means it's a we want to use it to the Linux Ubuntu, it's a entire system, means we can update, means that case we can packages and updates, it's a like kind of things is a getting, means it's a means it's a security wise it's a less to the particular hardware if you take into the particular hardware. But here it's a only required components only included, it's a particular board in Acto. Development time quick to set up and use, means here to so all are in free builds only, so that's why here we can quick to set up and use. Required time to configure and build. So here we are implementing things in scratch onwards, so that's why it's a required time to the configure and build. And license harder to track license for the include packages and easier to ensure compliance with open source licenses. Okay, I mean it's easy to track if you here it's easy to track, means it's only for a particular board only, so that's why. But here is the entire system, it's like that, so that's why here it's is not easy to track. Acto build process, it's a simple steps. First set up the build environment, install required dependencies before starting, install necessary packages based on Linux distributions like vget and git and gcc to all our Python and all the necessary packages we need to install. And then it's a download the Poki, it's a Acto reference distribution, it's a Poki, download Poki. So here we are using to the git clone actoproject.org Poki git, and going to this particular directory and check out the example. It's a here it's a some Crickstone and Miclidor. It's having different distributions we Acto releases, it's based on that we can check out that branch and we can do. And source to build an environment, here it's a we can when the run that the source voe init build env, hit going to the particular directory, then it's then you can going to the build directory. See the going to the build directory, it's going to the build directory, then configure and build and modify the config local.config for target architecture and parallelism and layers, we can do that. And we can set it up, we have to, whenever it's open to the particular configuration file, we can set it up the mission means here it's a which board we are doing to the target board, it's like here it's ARM64 or you can BeagleBone or TDA4 board, all those things we can set it up. And then parallel task, how many parallel tasks and how many number of threads we can running. It's a parallel makes it some manager, means it's a running to the 8 it's a parallel thread, it's like that. Okay, here to select the target, here only local.config configuration it's we can do it, all those things. And next, build the images by using bit by core image minimal, by using this we can do that building the images. After that we after set it up that target and parallelisms and all those things, we can build that by using this command and flash or run that command. And this is the just a simple test steps. Here this is the file you can flash into the machine addresses, everything. Here this is the core image minimal.wic. This is the image file. It's a basic important. Okay, yeah, like, thank you for comments and subscribe. Thank you.